Okay, so there's like a couple of questions that I kind of have here that are sort of rolled into one, and it just sort of they all seem to kind of slide together just based on what you've said already. So I do apologize for yourself and for people listening if this is a bit muddled, especially just because I'm used to talking about politics and economics as much as I love neuroscience and discussions about consciousness and all these things. It's not my like absolute like wheelhouse, so sometimes the words might get a bit fumbled. But anyway, so basically, the first question I have is do the children who have no cortex then they have no memory as such, and then like leading from that, does that mean that the memory isn't key to consciousness? That's not like that's not the basis of it. And I think there's you said in the book that there's like that little mesh that connects to the brainstem that's 525 million years old, and that so my question is basically like, is consciousness that old, or is that just like where it was first possible from? And then is memory the thing that sets humans' consciousness apart from, say, the rest of the animal world, if that's even the case? Like, I'm not suggesting that humans are definitely like more conscious, but yeah, could you try and tackle that for me?
Yeah, sure. So that is a sort of series of questions that interdigitate with each other. Let me start by saying those kids, they cannot remember consciously. They can never retrieve a memory image. In fact, worse than that, they can never generate an image, even here and now, because that's what cortex does. It generates images, and then it retains those patterns, and then you can reactivate those patterns, and that's what memory is in the form that we remember it. But the whole of learning does not coincide with that kind of remembering. So those kids don't have that, full stop, they don't. But then underneath the cortex, there's structures which we call the basal ganglia, subcortical nuclei. They're also capable of learning. But that kind of learning is sort of like learning a skill, like how to walk, how to move and grasp something, how to, at a higher level, sort of how to ride a bicycle, drive a car, play the piano, and so on. You don't have images in your mind remembering all your lessons. You just can do it. You just have motor patterns that run themselves. And these kids, most of them can learn like that. In other words, they can acquire simple skills and simple habits without necessarily being able to remember how they acquired them. They just do acquire them. I say some of them because it depends. Some of them have no cortex. Some of them have no cortex and no basal ganglia. The ones who have no basal ganglia, they don't learn at all, but they still have feelings. Now, before I talk to you about the animal stuff that you asked about and the evolutionary stuff, I want to go back to what you said about that sort of magical transition from automatic autonomic functioning to choice, to voluntary action. And I'd like to use the example of respiratory control. We all breathe automatically. You don't have to picture, oh, I need to breathe, and out, in, out. You don't think about it at all. Your body just does it. And when I say your body just does it, what I mean is your brain just does it without any consciousness. It's an automatic reflex governed by the brain. And that serves you perfectly well until you move into a situation where that kind of automatic reflex doesn't do its job. So imagine you're now in a carbon dioxide-filled room. This is an unexpected situation. It's not what your respiratory system is designed for, and you can't get enough oxygen. So now you have to make choices about where do I go? What do I do? Do I go up? Do I go down? Do I go through that door? Do I go through this door? How do you know? which is the right way to go. You have no basis for knowing because you've never been in a burning building before, let alone this particular one. And so now your need for oxygen becomes conscious. You feel this unpleasant thing we call air hunger or suffocation alarm. And as you move around, some of your choices will lead to increased oxygen. Some will lead to decreased oxygen. How do you know? It feels better or it feels worse. That's the function of consciousness, or in this most basic form that we're talking about now, the form that those kids, even the ones who can't remember anything, they would have that feeling, can't breathe. They don't know what that means. They just know it's not nice. And they know that it's nice to be able to breathe again. So that's how that part of our brains works, so that you make your choices according to what feels better, and you avoid what feels worse, and you approach what feels better. And in this way, you save your life. If you just had a reflex which says, well, just breathe, it wouldn't work. You need now to make choices about where to go in order to find the oxygen. And the feeling tells you the good or bad feeling of getting enough oxygen or not tells you whether you've made the right choices or not. Now add to that the capacity for learning, so that the next time you find yourself in a situation like that, you've learned, when you're in a burning building, go downstairs, not upstairs. The oxygen is down, not up. That's what I learned last time. So I'm using a kind of an extreme example, but generalize from that. That's what learning adds. So you don't need learning or memory in order to feel something, but it adds something. The feeling your way through the problem is how you learn, so that you learn from experience. The operative word is experience. You learn from, we call it the law of affect. You avoid what feels bad and you approach what feels good, and you predict on the basis of what happened last time what you're going to do next time. That's the whole function of memory. So that's the place of memory in relation to consciousness. So that comes back to your question about the evolution of all of it. So we know which parts of our brains, the brain stem, that the deep reticular activating system within it is where these feelings are generated. So we have every reason to believe that any other creature that has the same structures, regardless of whether they're able to learn or not, and regardless of whether they're able to cognitively elaborate it or not, we have reason to believe, because it applies in our case, that's a good basis for assuming the same applies in their case. And then you test your hypothesis by saying, well, I hypothesize, I know that in human beings, if you stimulate this part of the brainstem, they hate it. And if you stimulate this part, it's orgasmically delightful. Let's see whether the animals they want this stimulation or they avoid this stimulation. And every time we've done that experiment, our prediction is confirmed. The animals behave in the way that we would expect based on what those structures do in our own case. They do the same thing in the case of those animals. So on that basis, we believe that as long as you've got a brain stem with the reticular activating system inside of it, then you can have feelings. That's what emerged 525 million years ago. That's when the first vertebrates, I was going to say walked on the surface of the earth, but really actually slithered on the surface of the earth. So it goes against our intuition. But I believe the evidence leads to the conclusion that every vertebrate, in other words, every animal that has a brainstem with a reticular activating system, has feelings. Now, as you go to more complex creatures, so the capacity to learn from experience in the way that I've just described applies. In other words, as long as they've got basal ganglia as the subcortical memory systems, they learn. And then over and above that, those that have got cortex, which is mammals. Mammals have cortex. not only primates, all mammals, so dogs and cats and mice, and squirrels, and so on, and of course elephants and dolphins and whales, and all of us mammals. There's every reason to believe that they don't only learn, but they are able to replay, to be able to reactivate the actual images consciously. All of that stuff comes later. Now, so in all of this roundabout way, I've gotten, I think, to the nub of your question, which is what is uniquely human about human consciousness. Well, it is not that we feel, because fishes feel. Okay, that's what I was basically saying earlier. I'm sorry to say it, but fishes feel, and it's not that we can learn. You don't have to consciously learn. Many creatures learn. We can demonstrate it. You can see they learn. You can show that they learn. That doesn't mean that they are actually able to replay little movies in their heads about what they've just done. But that all mammals can do. Even rats can do that. So that's not what it makes us unique either. It's not that we are able to replay the experience in our mind's eye. And there's lots of good evidence that even rats can do that, although they have just a smidgen of cortex. Animals like whales and elephants, I mean, their capacity in this regard is fantastic. So what is it that makes us unique? It's none of those things. It's language. It's language. And it's not as if whales have a sort of a language, dolphins have a sort of a language, primates have a sort of a language, elephants too, but they're very basic, simple communicative schemes. What we have is this highly abstracted capacity for symbolic, for like there are things that you could not even think without language, like imagine something like but, yes, but. How do you think but, except in words? The very, how about not? How do you convey not? It's not true without an abstract symbolic system, like language. Let alone the precision that allows. I mean, think of the difference between probably, possibly, potentially. These are things, when I say those things, immediately what I mean. You can't have such ideas without language. Language is the vehicle for a kind of a symbolic, reflective, abstract way of thinking. Then I think that's where we come into our own. So I'm not denying that we humans have unique capacities. And I say again, I'm very glad to have them. That's also why we're able to have this conversation now, you and me.
Yeah.
But we mustn't confuse that with consciousness itself. We mustn't take our human version of consciousness as the sort of prototype. Why? Why is our consciousness what we should use as the defining type of consciousness? This is the most elaborated, most complex form of consciousness that exists on Earth. And if you're wanting to get to the essence of something, you don't start with the most complicated, elaborated version of it. You get down to the most basic version of it. Consciousness just is the capacity to feel like something, to actually have a qualitative, subjective, experiential, phenomenal state. And feelings are all you need in order to be able to have that. That's the most basic form of consciousness. And I'm focusing on that because I'm wanting to understand, how does it come about? How does this emerge from non-conscious mechanisms? That is truly a fantastically interesting scientific question.
Thanks for making it all the way to the end of the video. Don't forget to like, share, subscribe, and leave a comment for us in the comments below. Let me know what you thought and if you'd like to see more of this from the show. Thank you, and we'll see you again next time.